Okay, so in this video I want to derive the quotient rule and then use it in an example. So the quotient rule is when you get a problem that looks like this, where that's your function. You can't just come up with a simple polynomial for it by dividing. Well, not easily anyway. So you can't just use like the power rule on that. And it's definitely not the derivative of the top divided by the derivative of the bottom. So what we need is some new rule to approach things like this. So what I've done is up here, I'm defining f of x to be some x function on top divided by some x function on the bottom. And so I'm calling the top one h for high and the bottom one L for low. And the reason for that is there's a rhyme that helps you remember the quotient rule at the end. So, so over here, I'm going to rewrite f of x equals the high over the low function. And then a little trick I'm going to use, this is the same thing as saying h of x is really f of x times L of x. Now over here, really, this should also have the condition L of x can never be 0 because it's in our denominator. So we'll carry that all the way through. Now, a nice thing about this, I can take the derivative of both sides. H prime x is going to be the derivative of this whole side, which is also the same thing as saying like d dx of the whole thing, f sub x, or sorry, not sub, f of x times L of x, which is kind of like one of the ways that we've written out our product rule, because notice it's the derivative of something times something else, so we can use the product rule on that. So if I use the product rule, it's the first function times the derivative of the second function, which is this, plus the regular second function times the derivative of the first function, which is this. I'll put a times there just so you see it. Doesn't really matter. Okay, so that's what we have. And we want f prime. So I can rewrite this now. So let's get the L times f prime by itself. So it's going to be h prime of x minus f of x times L prime of x equals L of x times f prime x. And then if I divide everything by L on both sides, so divide by L here, divide by L here, then I've got f prime now. But if you look at the problem, it says in terms of these things, which doesn't include little f. So, but we know little f is h over L. So this guy right here is really h of x over L of x. So let me rewrite this now. So this is going to be h prime. I'm going to leave out all the parentheses x's. So let me rewrite this first like this. It's h prime minus f times L prime all over L equals f prime. And then this turns into h prime minus h over L times L prime all over L equals f prime. And then to get rid of the fraction in fractions, I'm going to multiply the top and bottom by L over L. So then f prime ends up being h prime times L, or I'm going to write this, L times h prime, minus, and then L times this thing, and so the L on top and the L on the bottom will cancel, and I'm left with h L prime over, and then L squared on the bottom. So if you wrote it all the way out, it would look like this. A lot of times you leave out all those extra x's, it's just implied. Like this. Now there's a little rhyme to help you remember it, and it's if you have f equals a high over a low, then what this says is it's low times the derivative of a high, so times d high, minus high times the derivative of the low, all over low squared. So the rhyme is this. It's low d high minus high d low over low squared, and away we go. And we'll practice that in class. This is one that pretty much every calculus teacher teaches their students at some point for the quotient rule. So if it's high over low, your answer ends up being low d high minus high d low over low squared, and away we go. So let's do an example with it, right? Oh, and the way that it would appear here, so this has a u and a v instead of a high and a low. So the derivative is going to be the low times d high, derivative of the high, minus high, derivative of the low, over low squared, like that. Okay, so let's do an example here. So I'm going to stick with highs and lows. So the top is a high and the bottom is a low, and I need the derivative. And I know the derivative is going to be low, derivative of the high, minus high, d low, over low squared, and away we go. So the low, x squared plus 1. The derivative of the high is the derivative of this thing, so that ends up being 3 times the derivative of x squared, which is 2x, minus the derivative of negative 1, which is 0. So that's low d high, low, derivative of the high, minus high, which is 3x squared minus 1, times the derivative of low, which is 2x plus 0, all over low squared, so x squared plus 1 all squared. And then I can do a little simplification. So let's see, this is going to be 6x, so 6x times x squared is 6x cubed, plus a 6x, minus, let's see, 2x times 3x squared will be 6x cubed again. And then 2x times negative 1 minus 2x, all over low squared, x squared plus 1 squared. So then the 6x cubes cancel, and I'm left with a 6x plus a 2x. So that becomes 8x on top, all over x squared plus 1, all squared. Okay, hope that helps.